which are very, very important for the examination point of view, as well as your, the internal point of view, and also for the, to understand how we can solve the, the problems, the mistakes, right? So here we are going to discuss about the error in tape or chaining that is due to the temperature variations, and also we are going to solve some of the problems like a river bank, the distances, and also for the obstacles, and another called a chain distance. Sometimes when you are doing the survey, there will be you may be by mistakes the chain length, it may be stretching the chain, it may be less or longer and than the usual one. So let us start with let me share the screen of that. So right, can you see the screen now, Chiranjeevi?
Yes, sir. We can.
Screens are visible. Okay, okay. So sorry, it's going somewhere. Right. Yeah. Here is the correction for tension. I mean tension in the sense pulling the chain and all, chain, or it may be a tape. Right. So in the last class, correction for the slopes. So it's in the right angles, correction for standard length, tape corrections. So these are all the corrections for standard length. Before using the tape, the actual length is sometimes like comparing it is with the standard tape. It's known as a length. So after stretching, what is some depends on the person to person. What will happen? Some people will stretch very longer way, very tight, so that the length will be little bit the increasing. Some people are just just keep the tape as it is. The length will be the vary. That is a lesser one, and the before one, that is a strength will be the less. So for that we must have some correction. Okay, this is how the things are here. Okay, how we are going to correct those errors. CA is equal to LC by L. So C is the correction for absolute length. Okay, and C is the correction for the correction to be applied to the tape, and L is the measured length of the line in meters, and it is another nominal length of the tape, actual length. Okay, so sign of correction will be the CA will be the same as that of the C. CA and CA will be the same. So this is how we are going to use some of the formulas for the correction of length when we are using the tape. Okay, right. So I have shared the notes, these notes for you guys. This is called as per your the syllabus, the same thing content will be followed with that, so that you can go through and PPT also I have shared in the Google Classrooms, so that you can refer all the PPTs as well as these notes, so that you can easily score very well in the exams, because it's completely it covered the entire syllabus. Okay, so here is the correction for slopes. Voice is audible, right? Chiranjeevi, Adarsh,
Yes,
the voice is audible. Okay, so this is correction for the slope, right? How we are going to correct the slopes when you are measuring the doing the any survey in the slope areas, how we are going to correct this? Because the length, see here, A, B, C. Okay, this is a slope of length. Okay, and this length is always the slope length is always greater than the horizontal length. So the distance measured along the slope is always greater than a horizontal distance. AC distance is very less. So when you consider this point is a horizontal, if it is in the sloping ground, so it's obviously it's a higher. So that's therefore, if the distance is measured on a slope, it must be immediately reduced to the corresponding horizontal line distance. This is a one. If you are doing the the survey on the plain land, no need to do the correction. If you are doing the survey in the hilly areas or in the undulating topography, these corrections, slope correction, you have to maintain that. That is called D is equal to square root of L square minus S squared. As you know this, L is the slope length, H is the height of the, the difference, from the C to B. So here, CL, slope length, slope corrections. SL means slope and C is the correction. C is equal to L minus T. Slope correction in the CL is equal to L minus, in bracket, L squared minus H squared. That is for 1 by 2, right? So here, this is, the simple, the calculation you have to make it, and to apply the square root here, and you'll get the final answer, L minus L plus H squared by 2 plus L plus H to the 4 by L. This is going on. Okay, this is how the thing, neglecting the higher order of strings. So H is equal to difference in elevations A and B, and L is the measured length in meters. Slope correction is always subtractive. Slope correction is always subtractive, not addition. Okay, because we have to minus this, actually this one, right? This is a correction for tension. When you are pulling the chain, when pulling the tape, how much it can be. Okay, if the pull applied to the tape during the measurement more than standard pull at which the tape was standardized, its length increases. Okay, hence the distance measured becomes less than the actual. Right. So this is another corrections. CP is equal to correction for tension. So for pull, CP is the correction for the pull. Okay, CP is equal to P minus P0 by E multiply with the L. Okay, and these are the correction. P0 is the standard fullness. P is the full applied during the measurement. Area for cross section, and E is the module of elasticity of the tape. That means stretching elasticity. Okay, some tapes are metal tapes, you cannot stretch it. Only the synthetic, or maybe if you are measured with your the nylon wire, if you measured it, okay, it's a 10 meter only. When you stretch it, it will be more than 10 meters. So that is how we need to do the corrections here. Okay, and L is the measured length. Tension correction is always positive. If the applied pull is more than the standard pull, and the negative if the applied pull is less than the standard pull. So it is always in the positive side. But when it comes to the, so when it comes to what you call this, the correction for slope, it is always in the positive side. Okay, and correction for temperature. You know that when you're doing the survey in this the site, it's so difficult. So when it, especially in the after 10 o'clock, after the 4 o'clock, there will be high temperature. The tape length changes due to the changes in the temperature while taking the measurement. That's the most important. But when you are using that metal tape, it will not going to happen like. But when you are using the tape such a way that the linear one, or it may be other one, so it stretches the temperature correction with the C1, which therefore needs to be C1, that's called C1. Okay, C1. So alpha within the bracket Tm minus T0 multiply with the L. Tm is the mean temperature during the measurement. T0 is the temperature of standard. It's a coefficient of thermal expansion of material. Okay, right. This is for a steel, for a other called the tape, invert tape. L is the measured length. Okay, and the correction is a positive if the temperature during the measurement is more than the standard temperature, and the negative. Okay, if the temperature during the measurement is less than the temperature, which is called a standardized tape. And another called is the sag corrections. So what do you mean by sag? So when the tape is stretched between 2 points, it takes the form of what you call the catenary, or assumed to be a parabola. Consequently, the measured length of is more, and the correction is applied. Okay, right. So this is another correction for this. These all the just derivations. Okay, based on this, we are going to solve some problems here. Okay, right. CA is equal to WL. Okay, W is the width and L is the length of this, and Sag corrections. If if there are n equal span per tape length, the correction per tape length is given by the CA. What do you mean by CA here? So here is a weight of the tape per meter length. Weight. So W is the total weight of the tape. Third one is the pull applied. That's called your N. And L1 is the length of tape suspended between the two supports. L is the small L is the length of the tape. Okay. Sag correction is always in the negative level. And this is another one called reduction to mean sea level. The length of line is measured at an altitude of h meter above mean sea level. That's called a mean sea level. It's always here you can see this. This is a height, this is a reduced level. Okay. So the necessity of reducing the distance to common datum arises. Okay. So when the surveys are to be connected to the national grid, you know that the necessity of reducing the distance to a common datum arises when the surveys are to be connected to the national grid. Okay, not in local grid. We have to connect to the national grid if we require, otherwise no. The correction denoted by CR is given by CR is equal to H by R multiplied with the L, where R is the radius of the earth. You know very well that the correction is always subtractive. This is a radius of the earth from here to here. Okay, okay, and H is then actually mean sea level altitude. Whatever you are looking at, that's completely what you say, that is mean sea level, or you can call it as a RL, or you can call it as elevation. That is always with respect to your mean sea level with respect to, right? As we discussed there, so when there is a contact, sea, beaches and the sea, the land and sea, that is called your zero. When you are traveling towards, when you are traveling towards sea, that will be the negative. When you are traveling towards uh, uh, when you travel towards what you call this when you travel towards land, that's a positive, that's called a plus, right? That's why we are always in the plus. We are on the land, we are in the plus side. We are, if you are in the sea, you are in the negative way. Okay, that's how that, just like that is a pond, you are out of the pond here in the land. Okay, the combined correction, combining corrections, it's actually practice each of the above correction based on the length recorded. Only the length correction we are doing, and the elevation another one. So which are combined by additions, but strictly speaking, correction should be combined by successive multiplications. Let us assume that given the length, the following unit of corrections has to be computed, which are to be applied. So sag correction, that will be the A, and unit slope correction B, and unit temperature correction C. True length is a L, and recorded length is a L dash. So then L is equal to actual length. L is equal to L dash, then bracket 1 plus A, close bracket 1 plus B, 1 plus C. Okay, so altogether the values of A, B, and C are very small, and hence the product can be neglected, eliminated such a product. Okay, that is a thing. So thus each correction of it can be based on the length recorded and combined additions. Okay, this is the thing. So what is the normal tension here? So pull or tension which applied in the tape suspended in the air equalize the correction due to the pull or a sag is known as a normal tensions. This is called another one. Okay, right. So here is the example of what you call this the problem which is based on the temperatures. So here I would give you the one of the what you call this the question paper which I'm going to share you by today. Okay, in the Google Classrooms, right? So this is a chain of, see here, this is how the problems are arising here. So 30-meter chain was tested. Okay, actually 30 meter before commencement of the day's work. It is a 30 meter, and okay, work and found to be a correct. Okay, and after measuring 3000 meters, that means 3 kilometers, the chain was to be a 5 meter too long. How it was? That is due to maybe stretching problems. Okay, at the end of the days work, after measuring 5400 meters, that means 5.4 kilometer. Okay, 1000 meters equal to 1 kilometer. Okay, so 5400 meter means 5.4 kilometers. So the chain was found to be 10 centimeter too long. Again, what was the true distance of chain? Okay, this type of problems will rise. Okay, and another type is that the a chain line ABC crosses rivers B and C being the near and distance bank respectively. Okay, so the respective bearing of C and A taken at D. Okay, at point 45 degree, sorry, at a point of 45 meters, measured at a right angle to AB from B or 300 degree and and uh, uh, 300 degree and 210 degree. The length of the AB is 24 meter. Find the width of the river. So, so to do the width of the river, find out the width of the river, you have to calculate all these things, right? Right. Then, okay. So here is the thing called problems which are related to the the distances. So related to the distance, right? Okay, so this is another one which are related to the temperature. A line was measured using the measured with a steel tape, which was exactly 30 meter at a temperature of 20 degrees centigrade, and a pull of the 10 kg. The tape. Okay, Adarsha, the voice is audible. It's clear.
Yes, sir.
Okay, screen is visible. All right. Okay.
Yes, sir.
Okay, the measured length was 1650 meters. The temperature during the measurement was 30 degree and the pull applied was 15 kg. Find the true length of line. What is the actual length? If the cross-sectional area of tape was 1025 centimeter square, the coefficient of expansion of the material of tape is some degree centigrade, that's called 3.5 into 10 to the power of minus 6, and modulus of elasticity, the stretching majority, the tape is 2.1 2.5 2.1 into 10 to the power of 6 kg per centimeter. How you are going to apply the correction to apply for correction for temperature and correction for full, there are two types. So as we applied the formula here, correction of temperature, C1 is equal to alpha within bracket Tm minus T0. We have all the values here, and 3.5 is that we have here, and that is a 1 here, and 10 to the power minus 6, and Tm 30 minus 20, 30 is here, and another coefficient 20, or what is the 20 here? Yes, minus 20 degree. Yeah, it's here. So 20 multiply with the 1650, that's a measured length, that's the mains here, that's your 0.05775 meter, that's a positive for temperature. Pulling, correction for pulling is the same. We have the values here and we need to apply these formulas, okay, to correct the pulling of corrections, right? This is how we know Cp is equal to P minus P0 by Ag multiply with the L. So all those values are here. Just you need to apply those values and get the final true length of the line. Okay, this is a thing. This is a very simple one. Using those formulas, you can apply this. Downhill of the 30 meter tape is held at 90 centimeter too low. What is a horizontal distance measured? So here downhill in the sense that's the slope. Okay, slope corrections. Correction for the slope h squared by 2l. H squared is the 0.9. Okay, h square is the 0.9. This is a 0.9. Okay, that's in meters. So don't think that, that's in a meters. Okay, by 2 by 30. Okay, so here is that 2L is the, there is a 30 here. That's all. Just to put this, the values here with the slope correction formulas, and you can calculate this horizontal distance. So here is the actual slope distance. Horizontal distance 30 meters. 30 minus 0.0135. You will get the horizontal distance. So this is how the correction which you need to be made for. Okay, this is also same for pulling this sag and horizontal distance. And okay, right. And this is with a baseline measured with a steel tape gives approximate length of 1000 meters. That means 1 kilometer. Compute the correct length of baseline at a mean sea level when the pull the standardized equal of 15 kg. The applied pull is 23 kg. The cross-sectional area of is 0.0645 centimeter square, and E is equal to 2.11 10 to the power of minus 6 kg per centimeter square. Temperature Tm and T2 are 35 and 15 degrees centigrade respectively. Okay, the coefficient of thermal expansion of the material of tape per degree centigrade is this much, 11.5 multiplied with the 10 to the power of minus 6. And the difference in the elevation level of two ends base is 2 meters only. So you give the R radius, that's 6,400 kilometer, and elevations of baseline above the mean sea level is 1,000 meters. The simple corrections what we did so far, this all the formulas, you apply it and easily you can solve this problem. See, look at this correction for pull. We have the formula is here and we have the things are here. So 23 pull is 23 minus P0 initial and final. So this is a 1 multiply with the L, that is a 1000 meters. So this is a level, right? You apply this and you will get the values. Correction for temperature, apply the temperature, the formulas and put the values. So correction for slopes, slope correction. You have the formulas, you can fill the things. Okay. So here correction for the mean sea level, CR is equal to H by R by multiply with the L. You have to do this. So this is how the total corrections of this thing. Corrected length for the baseline is this one. Okay. So whatever the values are coming here, so some are positive, some are negative based on the pulling is negative, sorry, the positive one. And when it comes to the correction of temperature, it's also positive. Correction for slope, it's a negative. Okay. So as we discussed, slope is always the greater than the horizontal distance. So that's why it's always in the negative portion. Okay. So here is the correction for sea level, that is also comes for this one. Okay. And these are all the the correction for measuring the distance in a horizontal ground as well as in the slope ground. Okay, that is the thing, right? And when it comes to the offsets, what is mean with offsets? The distance measured right or left of the chain line to locate the detail like boundaries, culverts, buildings. Offsets are called offsets on either side of the chain line. Okay, it's called the offsets, which shows the offset required to locate the corner of the buildings. That's one thing. And terms used in the process. The number of offsets required to locate the boundary will basically depends on the regularities. If more irregularities, more offset we need to take out. Irregularities of the boundaries being surveyed. Okay, and the offset should be at regular and close intervals, so that your survey will be the very accurate when you are taking the close intervals of offsets. Okay, but for such a spacing that that we have to representable scale or a plan for the given all the important details which should be located at additional check offsets. Two types of offset. One is perpendicular offset, another one is oblique offsets. See, here is the figure here. Okay, this is AB is the chain length. Okay, and this is your buildings. You are going to make the offset for this from this point. So when you are going to establish join, okay, the intermediate points, and you are going to what you call this offset with this. Okay, so here is the oblique offset, and this is a perpendicular. So oblique offset in the sense this is a perpendicular, it's a 90-degree, and it's a okay. That's all. This is a Chinese distance. This is a offset. This is actual survey line. From here, you are going to offset neighboring, means on either side of the your survey lines, right? To represent, yes, there is a building, and there is a pond, there is a the culvert here, there is a the footpath here. So when you are surveying particular line, on either side, if there is any features are there, if you want to project it, if you want to represent it, you have to do the offset from that point. So that is called your offset. So perpendicular, when the lateral measurement for locating the details or right angles to the chain line is called a perpendicular offset. This is a PR and QS. Here it is. PR and QS. These are the perpendicular and oblique offsets. Okay, oblique means when the lateral measurements for fixing the details which are not right angles to the chain. Here is the inclined one. Okay, line. Offset are called obliques. They are used to check the accuracy of perpendicular offset and to locate the corner building more accurately. It's called PR1. Okay, that's okay. So this limiting of offset is not too long. Okay, otherwise the error produced long offset will be no appreciable on paper. So it should be a very short distance. On either side means it is very short distance, not for a 100-meter, not for more than 100 meters. Okay, right. So these are all the some of the the corrections with the different instruments, tape, and with the other things, right? And here is the effects of error due to the directions. It is also happening in the field. Okay, right. And this is how the figures error in direction of that is going to happen there. Okay, this is the AB based lines, and you are going to make the offset for this particular one, and you are going to get the angle for this. Okay, and it gets it. So when you go to the next one, taking offset, okay, the error this ones, okay. So here is the establishing the perpendicular to the chain line. Okay, what is that? The most common method erecting the perpendicular to the chain line is the what you call 4.34 and 4.5 method. It uses Pythagoras theorems. Okay, and here is this is your chain line, straight line of that. Establishing perpendicular to the chain is this is the one. Okay, right. So what we need to do now, right? This is an offset is landing. Okay, it's a light of 4 degrees. This is another type of problems. Generally, the problems which are getting for the exam point of view, this like this, the area of plan of old survey plotted scale of 400 meters. Now it is square meters. So this is one type. Chain is maybe the plan is found to be have the strung, and so that line is originally 10 centimeter long. Now it is measured with a 9.7 centimeters. So sinking and stretching, these are the main things are here. Okay, and other one, the passing the obstacles in the form of ponds, stations, and AD lines. Main lines were taken. There are obstacle problems, and this type of problems are when you are stretching the chain. It may be a length may be increase or it may be a decrease. That is another type. And third type is that this is the same thing. Third type is that the distance of the river width. Okay, right. That is another type. There are 3 to 4 types of the problems will rise that. So all 3 types of problems are we are going to discuss here. This right. An offset is lied 4 degree out from its true direction in the field. 4-degree deviation will be there. Find the resulting displacement of plotted on the plan for the following cases. If the offset measured was 8 meters and scale of plotting is 6 to 1 centimeter, 6 meter to 1 centimeter. In the direction parallel to the chain line, in the direction perpendicular to the chain line. So what is the solution for this? So displacement of the point on a ground parallel to the chain line is L sine alpha. Uh, Alpha is the degree of this angle of inclinations, angle of deviations. So 8 meters is the measured offset. This is so very simple one. L sine alpha. So this is the things. L is 8 meters, alpha is a degree. So this is a displacement 0.558 centimeters. Okay. So now when it comes to the scale of plan is 6 meter to 1 centimeter. Displacement to the point is so L sine alpha by S. Right. So here we have the when you're plotting the scale is 6 meters. That is we have here. That is the symmetry, right? So here is the point of perpendicular to the ground to the chain line. So that is equal to L within bracket 1 minus cos alphas. So cos alphas from the calculator you can calculate it and you will get this values. Displacement point on the plan is that's called your 1. That's a 1 centimeter. Is for 1 here, is for 6 we calculated, and 1 for here. So these are all the problems which we are getting for the examination point of view. Okay. And here is the limiting offset so that displacement of the paper may not exceed 0.025 centimeter. Okay, the offset lied was 3 degree out from the true direction, actual direction, and the scale was 10 meters to 1 centimeter. As we discussed here in the last, same thing are here. Simple. Okay, deviation in the line, deviation from the main line, deviation from the surveying line. How many degrees are there? How much distance we have diverted that? Maybe knowingly or maybe unknowingly, or maybe a human error. Okay, these are all the things, some of the problems. Displacement problems. Okay, right, same problems are here. Okay, this also the offset is 15 meters long and the scale of plotting is 1 centimeter equal to 30 meters. So also displacement one. Okay, right. And let's go to the other one called angular error in the laying of the perpendicular direction of an offset was found to be a 5 degrees. So what should be the accuracy with which the offset should be measured so that the maximum displacement of point on a paper from both the sources of error be the same? It's a very simple one. So L sine theta, L sine alpha is equal to L by R. So L sine theta means 5 degrees. That's equal to L by R. So cross multiplication R is equal to sine by cosine. So 5 degrees. Okay. So 11.47. Hence the offset must be measured with an accuracy of 1 in 11.47 meter. Okay. So how you are going to handle the board, folks? This is the most important. When you are going for the survey, you must have the field book which we need to enter your elevation data, survey data, offset data, and your almost all the data you need to enter with. The distance you are going to take, bearings you are going to take, and the offset you are going to take, cross section you are going to take, longitudinal sections you are going to take. For all this, you must have the entering into the field books. Okay. Say for example, chain survey work is recorded in the notebook shown as a field book. That's we call it as a level book. Okay, which is the 200 mm by 120 mm size. That's a small book. The pages of the field book can be either red or line or maybe the two blue lines, whatever the things, apart from the roll down. Okay, middle page. The field work is recommenced from the bottom of the page and work in the upward in the directions. So this is about, lines. And okay, the following details are recorded, I mean, in the field in the commencement of the chain line. Okay, right. And here is the, right, number of chain of the lines, number of stations, symbol denoting in the station mark, direction on the survey lines, lines at the station. Initial chain is generally at 0. Okay, so this is field. This is actually the road. This is a what you call this, the buildings or maybe any settlements. Okay, and this is a benchmark. On either side you are going to establish the things, right? So this is how the field, right, how it looks like. So now let's go with the okay, right, booking in the record or in the data. Okay, right. Let me show you the the correction. Let me show you some of the level books. So how it looks, the level books, so that you can easily understand what is happening there. Great. The level books, yeah. Can you see the books now? It's visible. Adikeshu, Chiranjeevi. Hello.
Yes, sir.
Yeah, can you see the book? This is how the book we are maintaining in the what you call this, in the field. Okay. Okay. All right. So here is the backside reading, intermediate points there, and foresight. Okay. So it's it's the benchmark plant of glumations. It's the initial RL. Okay. All right. Then reduced RLs. Okay. What is the distance? C20. This is your reference. You can keep it as C20, C25, or it may be A20, A25, like that. That is up to you. Okay. All right. When you calculate this, and here is the minus of this 926.92 minus of this. Okay, no. 926.926, 930. Yeah, 930. 930 minus of this, 930 minus of this, you will get these values. Okay, altogether, check should be the, both should be minus 6, minus 0.06 or minus 0.6, whatever they should be the equal. Otherwise, somewhere problem with even your points. And each page you have to make those things. Here is corrections. Check corrections. Backside reading, intermediate reading. Okay, and all these things. That is this. Right. Check. For each page you have to make this. So that this is how they to maintain the record. Backside, intermediate, foresight, plant of galimations, reduced level, distance, and total distance. Right. So this is how we need to maintain the books. And finally, how we are going to know the RL calculation, height of the instruments minus foresight. So height of the instruments, how we are going to calculate? So RL plus backside, actual RL plus backside. This is a formulas which you are going to add to the field level. Okay, in the field itself. Okay, right. Just for an the information, I told you that how we are going to calculate, how we are going to maintain the what you call this the level books or field books. Okay, just keep it in mind that. Right. Yeah. Correct. So here is the obstacles in chaining. Okay, what are the obstacles will come in the chaining measurements? First method is the, this is the areas where we are going to get the problem. Second method is like this. Okay, third methods. Okay, so the first method ABCD be a line of obstacle by the pond. So if you want to survey these areas and there will be a pond, small pond will be there. How you, this is for your obstacles. I would say it's an obstacle. The problem consists of finding out the distance of BC because there is a pond. You cannot traverse, you cannot cross it. How we are going to do that? To offset BE and CF, BE and CF. You have to measure BC, but we cannot measure directly because there is a pond. How we need to, you have to take the offset of this BE and CE. So then you can proceed. To offset B and CF for equal length or made at B and C. Chaining is done along the EF. Okay, the work continuing from the C point. So you take both sides and measure this length, and this should be the same. Okay, no need to enter into the pond. Okay, this is how you do. Just take the deviations with a proper measurement. That's it. Second method is let DAB is the chain of line obstacle to the river. Okay, lay of AC. Okay, of any convenient length and perpendicular to the required distance AB. Okay, DAB. Where is that? Here it comes here. See, 2.33. This is another one, right? Where is this? DAB, second method, DAB, let the change. These are all the obstacles. How we are going to avoid this? How we are going to make the distance? That is the thing here, right? And here is the reverse, other ones. Okay. If any convenient length perpendicular to the required AB and lay of DC perpendicular to BC, then AB is equal to AC squared by AD. Okay, AC squared by AD. That is how you need to take the things. And here also same, this is a reverse. Third method, let the AB is the chain line obstacle by the river. AB is the chain line obstacle by the, yes, river. How you are going to measure it? Okay, assume a point L is anywhere in the line in the required distance AB, then take a H in such a way that here I is AB. Okay, and HA is equal to HI and HK is equal to HB. This is, it's just like a mirror of this. HK is equal to HB. So those things you need to take care when you are in the field. Okay, it may not be the case. You may not get this type of situation there in the field. But naturally, when you are joined for in companies as a surveyor, right? That time it is going to, it may happen. Okay, because I'm not sure it's going to happen this case because you have the GPS and all everything. You can directly cross the the river by the bridge and you can take the length of that also. Okay, that is the latest this one. But this is a basic information how we are going to determine how we are going to get the problems in the field itself. Okay, right. These are all the some of the things by the rivers. Based on this, there will be some problems. Right. Okay. Right. So here is the the some of the problems. A chain line is ABC crosses river at 90 degree as shown in the figure 2.37. This is a one. So B and C are 2 points located at near and far banks. B and C. Okay. Right. And respectively AB is equal to 57.73 and BD is equal to 100. Okay, and the angle ABD that's equal to 90 degree here. Okay, this is a mirror of this, right? The whole circle magnetic bearing will be whole circle bearing. WCB means whole circle bearing of C and E taken at D or at 30 degrees. Okay, and respectively find the width of the river. We need to find the what is the width of the river. Okay, whole circle bearing, this 30 degree I given 120 here, 30 plus 90, 120 here, whole circle bearing of AD and 120 minus 30. So when you apply all this, the degrees and angles here, and lastly BD square 100 the square here. This is the actual length, okay, and the actual distance of this I'm getting here BD square by EB. Actually, width of the river will be 173. All the formulas are here. Just you need to apply this. Okay, so this is another example of where there is a pond or something else in the obstacles. Okay, so in the next class we will these are all the problems which we may face in any one of the river. So here is a pond or maybe the river. Okay, see here opposite sides of the pond that we are looking here. Or it may be it can call it as a river. Just we discussed there how we are pushing the river's length of that degrees and find the width of the river. So this is how the the problems are coming, right? So this is one type of problems, right? That's a very simple problems. Okay. So this notes have shared in your Google Classroom, and you can go through the things. Okay, and you can work out for the many more problems. Okay, I'm going to share these the question papers. So in the Google Classroom, so that you can easily start to doing working on the previous question paper. That will helpful for your main exams as well as for internal exam also. Right then, just a minute. Okay, let me take the attendance here. Okay, Adarsh, quick.
Yes, sir.
Okay, Adarsh is right, and yeah. Okay, Adikeshav, Bharat.
Yes, sir.
Okay, Chiranjeevi,
Present.
Darshini,
Yes, sir.
Dashrath.
Present, sir.
Okay, Deepti,
Yes, sir.
Dhananjay, yes.
Yes, sir.
Okay, Divyasri, Gopi Reddy,
Present, sir.
Gopi Reddy. Okay, Guda Sai K Reddy. Okay, Harini.
Present, sir.
Okay, Harshavardhan,
Yes, sir.
Harshita,
Present, sir.
Hitesh Gowda,
Present, sir.
Kushal, Leoson, no. Okay, Madan Kumar,
Present, sir.
Manish,
Yes,
Manohar,
sir.
Manoj Kumar,
Sir.
Manoj M, Mohammad Sanif.
Yes, sir.
Okay, so Mohan,
Present, sir.
Neha,
Present, sir.
Nitish Kumar, Nitish Kumar. Okay, Renuka,
Present, sir.
Rohit, DM.
Present, sir.
Right, Sampath,
Present, sir.
Shahina? Okay. Shaikh? Shaikh
Present,
Asri?
sir.
Okay. Right. Sampath, Sharat Kumar?
Present, sir.
Shashank? Shiv Prasad?
Present, sir.
Shashank? Okay. Shraddha Patil?
Present, sir.
Sreshta?
Present, sir.
Sridhar?
Present, sir.
Taib? Taib Amin? Syed Nizamuddin?
Sir, Tayyab present, sir.
Present, okay. Syed Nizamuddin?
Present, sir.
Okay. Tarun?
Present, sir.
Varsha? Varsha? Okay. Vistrut?
Present, sir.
Yadunandan?
Present, sir.
Suman Patel? Suman Patel. Okay. Right then. So in the last.
Sir. Kushal present.
Kushal, right.
Yes, sir.
ಏನಪ್ಪ number ಏನಪ್ಪ ನಿಂದು?
17, sir. 17.
17, Kushal Goda. ಎಲ್ಲಿದ್ದು? Where are you? Don't.
Sir, I was attending, sir. I forgot to answer.
Yes. Oh, don't forget things here. Okay. So in the next class, we will solve some more problems which is related, distance measurement. Okay. Distance measurement. So far we discussed chaining, temperature, a river bank, and obstacles. So in the next class, we will discuss on the problems of distance measurement. Okay. And after that, let's move to the model 2. Okay. Right. Adarsha, Bharat Singh, Chiranjeevi,
Sir.
you have any doubts on this?
No doubt, sir.
So, okay, right then. Thank you very much. See you in the next class.